Okay, what is an angle in standard position? That's the question we want to answer today. And what does that mean? And why would we need a standard position? Okay, so the first thing we need to talk about is a standard position. Well, why do we need an angle in standard position? You can measure angles any way, right? I can do them this way, like this way. Why do we want a standard position? Well, it'd be nice if we're consistent. So everyone's saying the same thing and measuring angles the same way. And so we're going to have, in standard position, if we have a quadrant, the one you're used to, the Cartesian plane, usually we like to start things off from 0. Okay? And so 0, what's agreed upon in the math world, is going to be the positive x-axis. So from the positive x-axis, I'm going to grab my... Not on the positive axis. So yes, it begins at 0, 0, but the initial arm is not along the positive x-axis. So we're going to practice drawing some angles. So let's start with 75 degrees. Uh-oh, don't move like that. I have to lock my stuff in place. So 75 degrees. The first thing we want to draw is our initial arm, and our initial arm is always on the positive x-axis, right? So there's my initial arm. Now 75 degrees, when you have a Cartesian plane, oops, that's not blue. This is 0. What would be this first, the top vertical? 90 degrees, right? That would make a 90. Each one, we move 90 degrees more. So next would be 180, 270, and then if we went all the way around, the 0 could also be 360. Okay? So we want to move 75 degrees. We're still going to be in quadrant 1. So that's going to be approximately something like that. Okay, so here is my 75 degree angle. So 105, we have 0, 90, and then 180 is over here. We're going to be in quadrant 2. So we have to draw our initial arm, and we need to draw our second one. So approximately I don't know, we're going to approximate it. We're not going to use protractors. And so our rotation angle is this full angle here, 105 degrees. It says use a protractor. I should delete that. I'm not going to use protractor. Okay, last one, 225. What quadrant will that be in? Oh, 3. Yeah. So if you forget your quadrants, remember quadrant 1, top right, and we move counterclockwise, 2, 3, 4. Those are our quadrants. So 225 will be somewhere halfway-ish. And I need my rotation, my initial arm and a rotation angle, or sorry, our initial arm and our terminal arm to make the rotation angle. So this full thing would be 225. Okay. So on a side note, I want to talk about reference angles. Okay. So reference angles is the distance in degrees, so it's an angle, from the terminal arm to the closest x-axis. I like to refer to them as the bow tie angles. So what I mean by that is if I have, here's my Cartesian plane. So if it's a quadrant 1, the reference angle would be the same thing as the rotation angle. Be right there. Okay. If your angle is in quadrant 2, the reference angle will be between the terminal arm and the closest x-axis, so right there. Okay, that angle between the x-axis and the terminal arm. If your terminal arm is in quadrant 3, between the x-axis and the terminal arm would be right there. If you're in quadrant 4, the reference angle would be right here, between the x-axis, the closest x-axis, and the terminal arm. So you can see it kind of makes, I don't know, it's the angles within the bow tie. Those are the reference angles. So for example, the second example here, well, in the very first, your rotation angle is 75 degrees. And any rotation angle is just theta. So if I'm ever asking for theta, I'm talking about the full rotation angle. If I want the reference angle, I have to specifically say or use the notation theta r. Okay, that's the reference angle. Now in quadrant 1, the reference angle and rotation angle are the same thing. So it'd still be 75. Right? Here, rotation angle was 105. What would be the reference angle? What would be the reference angle? How could I get that? Any guesses? Just take those out. Yeah, Ryan?
180 minus 105.
180 minus 105. If we want the angle between the rotation arm and, so right there, if that's what we want, it's 180 minus 105, which is 75 degrees. Okay, so this would be this theta reference is 75. So this last one here, rotation angle was 225, theta r, or reference. How could I get the reference angle, which is the angle between the x-axis and the terminal arm? How could I get that little angle there? Yeah. Oh, I should, Braden. No. Yeah. Ryan?
225 minus 180.
225 minus 180. Because we want the angle between, right? This little angle here, the purple one, this is the one I want, not this one. So you have to do the 225 minus 180. So minus this, we want to take away the 180 and we'd be left with this angle. So that's how we get, I think that's 45 degrees, which is why I said it was halfway. Okay? All right, turn the page. I want to mention one more thing. You don't have to turn back. You can just look. I just want to talk about why reference angles are important. Okay? So, it's not on, is it? Sorry. It's on. Okay, reference angles are important because they share something really special with the rotation angle. So, for example, in this second one we did, if I type in sine 105 and sine 75, okay, so just really quickly, sine 105 and sine 75. In this case, what do you notice? Exact same ratio, right? They share the exact same ratio. If I did say cos 105 and cos 75, are they the same? No, one's positive, one's negative, but are the numbers the same? Yeah, so the sign might be different, but they still share that same ratio of sides. Or if I did tan 75 and tan 105, okay? They're going to share, the ratio might not be the same sign, but they do share the same ratio. And so that's why they're special. That's why we talk about reference angles. Okay, we can use our reference angle to figure out our angles and as well as our ratios. Okay, so quadrants, we talked about that already. 1, 2, 3, 4. That's nothing new. We're going to really quickly move into coterminal angles. This is a concept you really focus a lot. You focus in on a lot of, sorry, I can't speak today. Can't word. In Math 30, you will talk about rotation angles a lot, or at least more than Math 20. So with a rotation angles have the same terminal arm but different angle measurements. Same terminal arm but different angle measurements. That's a coterminal. So for example, 40 degrees and 400 degrees. Both share the same terminal arm, but are different measurements. Notice here's 40. If I wanted to go 400 degrees, I'd have to go a full circle around, 360 plus 40 more. 360 plus 40. Okay. Another coterminal angle would be if we went twice around plus 40 more. So 720 plus 40, 760. So we keep rotating around, an extra rotation and an extra rotation. So 760 would be if this is my terminal arm here, and I went once, so there's 360, twice, there's 720, and then plus the 40 more. That would have the same terminal arm, it's a different angle, but same terminal arm, okay? So let's say we had a rotation angle of 50. Can you give me another rotation angle that would be coterminal? Co meaning coexist, like together, terminal, the terminal arm. So same terminal arm. Yeah? 410. All we have to do is add or subtract 360. Yeah, you can also go, there is such thing as a negative angle. So a negative angle, which is really odd, because normally we say distances aren't negative, but you can have a negative angle when we're talking about standard position, because we say positive angles are counterclockwise. So a negative angle, which is what you'll talk more in Math 30 about, would be clockwise direction. So if I wanted to go at an angle of, so for example, another coterminal would be 50 minus 360, which is negative 310. So instead, if we went this direction, as opposed to, we went clockwise instead of counterclockwise. Okay, it's going the opposite direction. I just wanted to introduce the terminology. It's not a big focus of this unit, so we can just move on. Okay, it's very, very, it's nice for you to see it a little bit before Math 30. We talked about reference angles. One thing I didn't really say is that a reference angle isn't always acute. It's less than 90 degrees. Because it's the angle between the terminal arm and the x-axis, it'll always be under 90. Your reference angle is always in the same quadrant as the terminal arm. So let's look at these guys. Let's draw 230 degrees. What quadrant will it be in? 3. Good. So 230, we'll just approximate it. So I have my initial arm, and I have my terminal arm. And there's my angle, rotation angle of 230 degrees. Okay, that's my theta. Now it says, label the reference angle. So how could I get the reference angle here?
230 minus 180.
230 minus, so whenever you're in quadrant 3, it's going to be, to get your reference angle in quadrant 3, it's always, 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 your reference will equal to your rotation angle minus 180. every time. Doesn't matter what the angle is. So in this case, my rotation angle was 230. Take away 180, which is 50 degrees. Okay, so it's going to be, let's use purple. This little angle right in here, this is 50. Theta R. Okay. Try the next one. Draw 110, determine the reference angle. Okay, so remember your reference angle is the bow tie angle. So it's the angle between the x-axis and the terminal arm. Yeah, Chase? 70. So in this case, it would be 70 because it has to touch the x-axis. Okay, reference angles never touch the y-axis. They always have to touch the x-axis and the terminal arm. So how did you get that? What did you do? So 180 minus 110. So you took 180 and you took away your rotation angle. So in quadrant 2, to get your reference, it'll always be that 180 minus the rotation angle. So in this case was 180 minus 110. So 70. Okay? That's your rotation. That was our reference here. On a side note, if you're in quadrant 1, how would I get my reference angle in quadrant 1? So if you have a rotation angle, say of 70 degrees in quadrant 1. Nope. Nope. Yeah?
It's just the angle.
It is the angle. So it's nothing special. In reference 1, rotation angle and theta are the exact same thing. Okay? You don't, because we always want the angle touching the x-axis. Well, that is the angle touching the x-axis. So in quadrant 1, oops, I forgot to say the quadrant. Let's write 1. Quadrant 1. Now it looks like a sideways base, but anyways. Okay, so quadrant 1 is the same. How about quadrant 4? So let's think about quadrant 4. I'll draw a quick image. So if I had an angle here, say of 310 degrees, how could I get the reference angle? Anyway, now. 360 minus 10. Yeah, because we want this angle right here, right? We want between the x-axis and the terminal arm. That's going to be your reference. So in quadrant 4, your reference will always equal 360 minus the rotation angle that you have. So in this case, would be 50 degrees. Oh, that's okay. So 50 degrees. Okay. So that's how we get our reference angles. Didn't really have much room to write that, did you? Okay, so moving on. The last page of this lesson. Draw 4 reference angles. Sorry, draw 4 angles with a reference angle of 20 degrees. Okay, we're going to draw 4 angles that have a reference angle of 20 degrees. There's a reason why I said 4. 1 for each quadrant. Quadrant 1 we'll draw 2, 3, and 4. Quadrant 1 is the easiest. Why? It's just 20. Remember that your rotation angle and your reference angle are the same thing. So if we draw this, here's my 20 degrees. Okay, where is the 20 degrees going in the second example? Is it going up here, the first arm, or the second arm? The second arm, right? Because we want 20 degrees between the x-axis and the terminal arm. So this would be your reference of 20. What would be the rotation angle? How could I get it was 160. So 180 minus the reference. So your rotation angle here would have to be 160 degrees. This was 20. Quadrant 3. So remember the bow tie angle? The angle between the x-axis. And so that's my reference of 20. How would I get the rotation angle in quadrant 3? (180 plus 20). So 180 plus your reference. So 180 plus 20 gives you 200 degrees. And the last one, that's 20 degrees. Right? We want the angle between the x-axis and terminal arm. That's a reference. That's 20. So how would I get the rotation angle? This rotation angle here. Let's use green. 360 minus 20. So quadrant 4 is always, oh, that's not. Let's try it again. Your rotation angle would be 360 minus your reference. So 360 minus 20 is 340 degrees. Okay. So mostly this lesson is about understanding the terminology, understanding what is an angle in standard position, and what is a reference angle. Those are the two big concepts you need to walk away with today. So I'd like you to try number 3 on your own. Draw it, and then determine the reference angle. Okay?